somewhere north of the Arctic Circle, in temperatures that would turn your eyelashes into icicles, Inuit builders figured out something most modern engineers still find impressive: how to build a warm house out of the coldest material on Earth. Yes, warm. An igloo's interior can sit around 16 degrees Celsius above the outside temperature, powered by nothing but body heat and a small oil lamp. No insulation panels, no thermostats, just snow, geometry, and a very specific kind of patience. Let's start with the raw material, because not all snow is created equal. You can't build an igloo out of the fluffy powder you'd want for skiing. That stuff is basically frozen air, and it collapses the moment you try to stack it. What builders look for is wind-packed snow, the kind that's been compressed by Arctic gusts until it's dense enough to hold weight. A good way to test it: push a long knife or snow probe into the surface. If it slides in smoothly without cracking apart, that's your quarry. Once the site is chosen, the real cutting begins. Builders use a snow knife, traditionally carved from bone, now usually a long serrated blade, to cut rectangular blocks straight out of the ground. Each block is roughly 60 to 90 centimeters long, and here's the clever part. Cutting the blocks out of the building site itself digs a shallow pit, which becomes part of the sleeping area later. Nothing gets wasted. Zero waste construction site. Several centuries before, that was a marketing term. Now comes the part that actually separates an igloo from just a pile of snow blocks, and that's the spiral. Instead of building in flat, stacked rings like a brick wall, which, fun fact, would just collapse inward under its own weight, builders lay the blocks in a continuous rising spiral. Each block leans slightly inward and rests on the one before it, so the whole structure behaves less like a wall and more like a self-supporting dome. It's the same principle behind a Roman arch: individual pieces pushing against each other in compression, holding the whole thing up without a single nail, beam, or fastener. The angle is everything. Builders shave the top edge of each block at a slight slant, so the next one tilts inward just a bit more than the last. Get the angle wrong, and the dome either flares out and collapses, or curves in too fast and pinches shut like an ice cream cone gone wrong. Skilled builders can read this angle by eye, adjusting block by block as the structure rises, which is honestly a more impressive skill than most people's actual full-time jobs. As the spiral climbs, the diameter shrinks, and by the final rows, the blocks are nearly horizontal, capping the dome like a keystone. The very last block is often the trickiest. It has to be lowered in from outside, shaped to wedge perfectly into a hole that's already smaller than the block itself. Traditionally, this is done by cutting the final piece slightly oversized, then trimming it in place from inside the newly finished dome, which means at some point, someone is sitting inside a sealed ice structure, carving their own exit. Here's where the physics gets genuinely elegant. Snow, it turns out, is a fantastic insulator. Not because the ice itself is warm, obviously, but because it's full of tiny trapped air pockets. Similar to how a down jacket works, those air pockets barely conduct heat, so they act as a buffer between the freezing air outside and the warmer air your body generates inside. But trapping heat creates a new problem. The inside surface of the dome starts to melt slightly from body heat and lamp heat. Builders account for this on purpose, as that inner layer melts just a touch and then refreezes. It forms a thin shell of solid ice on the interior, essentially self-sealing the structure and making it stronger over time. In other words, the igloo is designed to slightly damage itself in exactly the right way. Ventilation is the next non-negotiable detail, because a sealed ice dome with people and an oil lamp inside is, without a vent, a very effective way to trap carbon dioxide. Builders cut a small hole near the top of the dome, positioned carefully. Too big, and you lose all your heat. Too small, and you lose consciousness, which is a considerably worse outcome. Some designs add a raised sleeping platform inside as well, because cold air sinks and warm air rises, so sleeping a foot or two higher than the entrance tunnel keeps the coldest air pooling near the floor. Speaking of entrances, igloos are almost never built with a straight doorway. Instead, there's typically a long, low tunnel leading in, sometimes dug slightly below the level of the main dome. This isn't decorative. Cold air is dense and sinks, so a sunken entrance tunnel acts as a cold trap, letting the coldest outside air pool low in the tunnel instead of flowing straight into the living space. It's a passive climate control system built entirely out of elevation and airflow. Centuries before anyone used the phrase passive climate control, put it all together. Compressed, wind-packed snow, a self-supporting spiral dome, trapped air insulation, a self-sealing ice shell, calculated ventilation, and a cold trap entrance. And you get a structure that can be built in a few hours with hand tools, requires zero imported materials, and can keep people alive in temperatures that would be lethal within minutes. It's less primitive shelter and more a master class in reading your environment and letting physics do the heavy lifting. Modern architects studying thermal efficiency and dome structures still reference igloo design, which is a pretty remarkable legacy for a house made entirely of the thing that's actively trying to kill you.